Hello, my name is Venkatesh Sridharan. I'm here to explain about my TOC final DSL project. I'll show you how the code is being designed and how it works by explaining the different components together. So first I'll start with what the actual project is. So my project is basically creating DSL to make the fitness applications development easy. That is my main goal. First project here is the draft proposal which I have submitted. I'm okay with sharing it with everybody so that they can take a look at it. And if you go into this project, we'll first start with the main architecture of the project, which is explained in this diagram. So mainly combine the DSL world and the voice recognition, which would give meaningful use to the DSL that I have created. So basically what happens is the user, in which case it would be me in this case, would speak to a voice recognition device. For the purpose of this project I have used the Alexa voice assistant, which is an open source voice recognition assistant which powers all the Amazon devices like Echo Dot, etc. Which first takes my voice input and it actually uses a DSL called SAML, which is a DSL for voice inputs, and it passes that and then it calls this function called AWS Lambda function, which is basically a serverless architecture function which just like responds to some event which you configure. In this case I have written code to configure it to respond to voice inputs. So once it uh, gets that voice input, it makes call to a service that I am hosting in Tomcat, which in turn it invokes the DSL that I have designed. so so this is the whole flow of the application, and this is the core DSL component. So we'll go one by one to see how they all work together to give the final output back to the user. So first let's look at the DSL component. So for the purpose of this project I have started with the DSL responding to two commands. They are like exercise command and nutrition command. So exercise command is basically you can say I did a particular exercise. In this case it's now supporting running, cycling and swimming in like so and so time, and this is the distance I ran, and it's going to respond back and give you some information about like how many uh, um, calories you burnt and then what's your speed and things like that. So that is the first command. The second command is the nutrition command, in which you can basically ask how many calories are in a particular food type. For now I only supported fruits in the code. I mean, I was trying to do fruits and vegetable, but for now I just made it just to make it simple to understand. I only did fruit now, but it can easily be extended for any type of food type. So if you want to look at the code, I have used Java for as the main programming language, and then so this is the BNF notation which we read in the class, and here is the um grammar definition using this framework called Antler. It makes it easy in that it actually generates all the lexer and parsers for you. So as you can see, here are all the terminal symbols, and then here are the non-terminal symbols over here, and then you have the actual production rule where you can say how white space many calories in a particular fruit, and then I did so and so count in so and so time. And for now the fruit is apple and orange. I have a to do here because it's not all fruits, but you can easily extend it to include as many as you want, or you can even go a step further to put it all in a database that you can query instead of relying on the grammar to be huge. So the grammar just can just identify some kind of a regular expression instead of having the fruits hard coded in it. The same way for exercise, for now I only have like running, walking, swimming, and cycling, but which can be easily extended as well. So this is the grammar definition, and once you run the Antler code, it basically generates a parser and lexer for you, which I think you can see in here. Generated sources. Yeah, so it actually generates this whole code base level with lexer and parser over here, and you have to extend that to write the actual logic as to how to handle a particular um string. So once it gets the command, it goes and parses it, and based on what type it is, whether it's an exercise type or a nutrition type, it calculates various attributes like distance, speed, calories, and things like that. The same way for fruit, it gets like the calorie information and how many grams of sugar does it have. Um, it's just gonna respond in a JSON format to make it easy for the consumers to consume it, so that we can make it as standardized as possible. So this is the DSL component, and now we can look at the web services component, which is basically a REST-easy web service. It follows the REST service protocol, and you can have this different endpoints over here where it takes input and then passes it to the actual lexer and parser and gets the output back and responds it back. So that's the one, and so that is what the service component is, and that service is currently hosted in Amazon EC2 instance. Is basically Amazon Web Services is basically an infrastructure as a service where you don't have to like invest on like any machine or hardware locally. So say my computer goes down today or tomorrow, I don't have to worry about that because I can like rent some VMs from Amazon Web Services, which will just like spin up VMs, and they also have free tier, which is what I'm using right now because my instance type is micro, which doesn't have a lot of RAM and hard drive, but it's okay because I'm just going to host a simple Tomcat web server over there. So it's running in here, and I already SSH'd into it, and I am running this project as a Docker container. If you don't know what Docker is, it's just a container framework which can be used to easily like ship, build, and deploy your code anywhere. You don't have to worry about going to each and every machine and worrying about the platform based dependency. If you have everything in a container, it can be deployed anywhere in any operating system. So that's the beauty of it. So I have the service running on that command line. So this is the proof that the service is running in port 8080, and the IP is this public DNS IP. Right now I haven't made any private connection, so you can actually hit the service from anywhere you want without any authentication, which can definitely be improved. Right now I'm not really worried about that. So the service is running here, and then the next component is going to be the AWS Lambda, which is in here. uh, so this is the UI for AWS, which has something called Lambda. It's all in terms of function. So in function you basically upload a jar to this. It supports various programming languages, so I use Java 8 in this case. So this is the flow of how it works. So the Alexa voice recognition, as I explained before, will trigger this fitness skill lambda function, which will in turn call my service, and all the skills log will be going to the CloudWatch, which you can go and look at it, and I'll show you how this works later. So the code for this is also in here. This is a DSL skill. So you actually configure different handler where you respond to all these different commands that come in as voice. So this is the nutrition intent handler, and then the exercise intent handler. The nutrition intent handler basically takes in the nutrition information command, like how many calories are there, and it calls the service which is hosted in that public IP as I mentioned before. And once it gets the output, it parses it and it responds back as speech over here. The same way, the exercise intent handler takes it, calls the service, responds back, and it has all those built-in handlers like for help and exit and launching the actual um, skill. So each and every uh, voice recognition ability you give to Alexa, they call it a skill, so that's how the term skill came into place. So that is the AWS Lambda part, and now we have the voice recognition part, which is over here. So you can actually create an Amazon developers account, go there and create a skill to your Alexa. I unfortunately don't have an Amazon Echo with me right now, but you can actually test it in the web UI either by typing or clicking. So right now I'm going to type and show you how this whole thing works. Let me see if it works. So first before anything, we need to give command to open that skill. So for that it's going to be like open and then the name of the skill. So in our case it's the fitness skill. So that would be open fitness skill.
Welcome to my fitness skill.
So that's the message I configured in the welcome message skill. For launch request, we go here. It's going to show welcome to my fitness skill, which is what I configured. So that's what it's going to say. And then we can actually give command and say tell fitness skill how many calories in apple. That's going to respond.
Apple has 76 calories with 8 grams of sugar.
That's the message that is configured in the that is coming out from the service. You can test it by actually confirm it by going to the lambda, because the lambda function would have been triggered. So we go to the monitoring piece of it. There is an invocation count which actually shows that these functions have been invoked. Um, so this is the CloudWatch log that I explained before. It's basically going to show you the logs. It's taking a little while to load. So while that is loading, I'll actually try to give a voice command instead of typing and see if it works. It's not picking up my accent that much, so hopefully it works. Let's see. Tell fitness skill how many calories in apple.
Apple has 76 calories with 8 grams of sugar.
Okay, that worked. I can do the same thing for orange as well and see if that works. Tell fitness skill how many calories in orange.
Orange has 40 calories with 5 grams of sugar.
Okay, so that is the nutrition command. I can also do the exercise command over here, and 6 miles.
Nice job. You have burned 420 calories and your speed is 6 miles per hour.
So there you go. It responded to my command over here, and I can actually look into the CloudWatch logs right now. So these are all the response I got from the service. That's what it's actually spitting out as voice. So all the logs are present here. So that's how the whole app works. Like you can see the whole connection in here. And so what's the future scope of this project? This can easily be extended, as I mentioned before, to support multiple food types or access a database to get all the information instead of relying on just 2 or 3 types of food. But I just wanted to show how the whole thing works with the DSL and how easy it would be for someone to write a fitness app using this DSL rather than having the same business logic in their code every time. And I have hosted my code on GitHub. There is 2 repos. One is for the actual DSL and other one is for the AWS Lambda. So you feel free to look into that. And if you want to make any changes, please log an issue and issue a pull request. I'll be happy to take it. So